Hey everybody, STEM Minority here. Last time we left off, we were talking about, or we were going over a trend or a research, I guess, finding where, I guess, a study showed that when it comes to education, a less controlling teaching style, and that you give the students more free will. So a less controlling teaching style shows a positive, shows an increase in intrinsic motivation, and that was done by a series of scientists. And I guess the test was centered around physical education and Spanish students. So if you haven't seen that video, go see it. I think it's kind of a cool finding. And now today we're gonna step into a new topic of discussion, or basically I'm just gonna find a random article and just simply talk about it. I know that yesterday, and by yesterday I mean at 12 a.m., that I would post 2 videos. That's not gonna happen. I think I'll just post, because tomorrow I have 3 tests, and on Saturday I have a mock MCAT. So, yeah, I'm going to keep posting a video, I'm going to post a video today, tomorrow, and even Saturday, but I think I won't start posting the multiple videos to make up for that lost time until Sunday. So, yeah, because it's hard being a scientist, hard being a not medical student, but just a bio student in general. So that being said, let's get started. So today I think I was more interested in alternative energy. So that being said, I just remembered. That being said, what I think I'll do with this channel is on a week by week basis. So the first week, I went over how to read an abstract. I won't post a video on the methods until the second week. So I'll just do it like that, where the first week, I taught you how to read an abstract. Next week, I'll teach you how to sort of what to look for in the methodology. Then the third week, I'll tell you about the different types of results you can get, and I'll go over, what kinds of results are out there, from types of graphs to how to interpret a graph to, how to interpret a image of a fluorescence image, because sometimes we tag certain proteins with antibodies, and that gives off a huge fluorescence, right? And then next week we'll talk about the discussions, which is same as the not really same as I shouldn't say that. It's same in its simplicity, in that the discussion, all it's talking about is what went on in an experiment, and then what are the various applications of such things. And then I think that's mostly it. I don't think people include conclusions, because I feel like in science there's never really truly a conclusion. There's more, because I feel like a conclusion's more, like, okay, this is a proof, and in science there's nothing really proven. There's just evidence. So I always see it ends at discussions, and for the reason that the evidence kind of leads way into stuff. Y'all get what I'm saying? So yeah, first week abstract, second week methodology, third week results, final week discussion, and then from that point on I'll just start talking about various various trends in science, and I'll just keep going like that until y'all until you give me something to look up that you want me to look up, or so on and so forth. Sorry about that. I like playing this game. I don't know why. I'm not a violent person, but yeah. So this week I was interested in alternative energy because that's always the talk of our nation. Just CO2 levels are rising, global warming. Yeah, I'm a global warming believer. So to all of you out there that's not a global warming believer, look, it's okay to hold differences. That's all I gotta say. That being said, you know what? Honestly, it's all kind of calculation of reaction. Let's go with this. 5 roads that converge at the cyclic peroxy Krige intermediates. So I guess Bf3 catalyzed synthesis of beta hydroperoxy peroxylactones. Okay, so I guess what it's saying is, from the title alone, it's saying that there are maybe 5 ways to get to this common intermediate, whatever it is, and because it says it's the cyclic peroxy Krige intermediate, which means it must be very common, and everybody must like to get to it. So maybe there's 5 ways to get to it. That's what I'm interpreting from that portion. And then Bf3 catalyzed, and I guess this is a series. Maybe there's 4 other ways in other papers, and this is the Bf3 catalyzed synthesis way. So Bf3 catalyzed, all you need to know is the reaction is sped up through introduction of Bf3, and I guess you're synthesizing beta hydroperoxy, beta peroxylactones, whatever those are. And I believe whatever that molecule is, it's involved in the cyclic peroxy Krige intermediates. Okay, like I said in How to Read Abstracts, if you don't know something, just take it and use a word in its place so that you understand it. I know a lot of you scientists out there might understand this stuff, but again, I'm a beginning scientist myself, so that being said, I'll continue. Oh, by the way, if you don't know something, yeah, do look it up. Yeah, do look it up, because now that I've read what a cyclic peroxy Krige intermediate is, the next step would be for me to look it up and see what implications of that there are. So that being said, our abstract starts off by, we have discovered synthetic access to beta hydroperoxy, beta peroxylactones via Bf3 catalyzed cyclizations. Again, this is just another way that they rewrote this. So they discovered a new way, which is a synthetic way, a new, I guess, like, not natural, but that's how you can interpret it. So a new synthetic access to making, this molecule via this route of a variety of acyclic precursors. So, yeah, it's, I guess, whatever this molecule is, it's belonging in this group of molecules. Let me reread it. We have discovered a synthetic access to beta hydroperoxy, beta peroxylactones via Bf3 catalyzed cyclization of a variety of acyclic precursors, beta kestoesters and their silyl enol esters, alkyl enol esters, enol acetates, and cyclic acetyls with hydrogen peroxide. So, those are just a majority of, those are just a plethora of chemicals that I guess are involved with this sort of cyclization or catalyzed cyclization. Strikingly independent of the choice of starting material, so you can use any of these and it doesn't matter, you'll get to the same result. So independent of the choice of starting material, these reactions converge at the same, right, like what I said before, the same beta-hydroperoxy, beta-peroxylactone products, i.e. the peroxy analogues of the previously elusive cyclic Krige intermediate. So I guess peroxy analogues are like more of the beginning step. So that's how you can look at it. Just maybe the peroxy analogues as in the steps before you get to the intermediate. So the peroxy analogues, and again, if I got that wrong, somebody who is more familiar with this paper, please let me know in the comments. The peroxy analogues of the previously elusive cyclic Krige intermediate of the Baeyer-Villiger reaction. So it's an analog in this cyclic Krige intermediate, and the Baeyer-Villiger reaction, this is a reaction in organic 2, and oh my god, I hope my Orgo teacher does not see this video because I real talk forgot the Baeyer-Villiger reaction, but it's basically an organic chemistry 2 reaction. I forgot how that went, but again, I'm going to look it up right after this and just, continue to learn. But in other words, any of these chemicals that you use will again converge at the beta-hydroperoxy, beta-peroxylactone product, and before going into the Krige intermediate or before going into this sort of molecule of this reaction. That's all you need to know. Computed thermodynamic parameters, so they analyzed it for the formation of the beta-hydroperoxy, beta-peroxylactones from, or these molecules from silyl, enol esters, enol. So from these various molecules confirm that the beta-peroxylactones indeed correspond to a deep energy minimum, that connects a variety of the interconverting oxygen-rich species at this combined potential energy surface. So I guess that another way to look at that is they analyzed that in order to form this molecule from these various compounds, they do kind of converge at this energy requirement that involves I guess oxygen-rich species. So chemicals that are really oxygen-rich at a certain energy point. And I guess I feel like for those of you that are sort of beginners, it would help to know the potential energy diagram, just sort of maybe have an idea, but I guess you could say there's an energy minimum to achieve the reaction, if that makes sense. Hopefully that's what it's saying, because I think that's what it's saying. The target, this chemical, or these chemicals were synthesized from beta keto esters and from these various chemicals, and it was obtained in moderate to high yields. These reactions proceed under mild conditions and open synthetic access to broad selection of these chemicals that are formed selectively, even in those cases when alternative oxidation pathways can be expected. So you can make these chemicals right here under mild conditions, under mild and various conditions, whereas before they were before only open to oxidative pathways. Or wait, maybe that's that are formed selectively even in those cases when alternative oxidation pathways can be expected. Oh, okay, never mind. So these can be formed. Sorry, not these can be formed under various conditions. Is the way you should interpret this. These can be formed under various conditions. So these beta peroxylactones are stable and can be useful for further synthetic transformations. So that's the, I guess, main takeaway from this. Okay. Funny thing is that I'm not sure if this has anything to do with alternative energy. All we're doing is making a chemical. So this is more of a synthesis paper. But in summarizing this, I guess what this paper found is that there is a new way to make the beta peroxylactones via Bf3, and that you can use this path through various chemicals, and that this is essential for forming I guess the Krejci intermediate via the Baeyer-Villiger reaction, which is, they're just a series of reactions that you can look up later, and that this process of making the molecule requires a certain amount of energy, which is somehow connected to oxygen-rich species, and that more importantly, they were able to yield this. They were able to yield medium to high yields, and that this can proceed under mild conditions. And at the end of all of this, that we are now able to make beta peroxylactones for other synthetic transformations. So I guess in short, there is a new way to make beta peroxylactones, in short, and this is the parameter. I would say this is the more, for those of you who are beginners, this is the more complicated of the two, especially if you don't have a background in chemistry, and this is very, very deep in chemistry. But again, when it comes to reading papers, just replace some of the words with words that you do know, and the paper will soon start to make sense. There are some bits where I feel like I had to stretch it, and I feel like my disadvantage in not being a chemistry major might be around here. Sorry, might be around here where you talk about interconvening or deep energy medium that connects a variety of interconverting oxygen-rich species at this combined potential energy surface. Maybe it's because I'm not a chemistry major. I'm having a hard time understanding that. But if there are any chemistry majors out there that do understand that, just drop in the comment. I'll edit the video to include what you guys mean. And yeah. So that being said, before I end this video, of course I must give credit to the authors. Vilva Jones GDP, I feel like that's it. Okay. Ekimova MV, Lysenko, Sureshkin, Nikishin, Ala Bugin, and Tarentev. Oh, Jesus. This is their paper. If you want to see it, I'll put it in the description. If you're a chemistry major, this might look interesting. So, that being said, hopefully you guys find this video helpful in understanding, again, more on how to read abstracts, and hopefully you found this new way to make beta peroxylactones equally interesting. So, that being said, I'm out.